Hello everyone, I'm Akhila, a second year PhD student at CDS Department IISc. Today I'm here to talk about the data science pipeline, which starts from collecting data all the way to modeling the data. So most of us are aware of the different data science applications, right? But when it comes to the definition of data science, there are numerous definitions for the same. Why is it? So that's because data science is an assortment of tasks, and based on the application, the emphasis on tasks are different. Hence, the different definitions. So, when it comes to healthcare industry, its definition to data science might be a little different than that of the marketing industry, right? But the underlying tasks that are involved are the same. So, let's now look into what are the tasks that are involved in data science pipeline. It starts from collecting data, followed by storing it, processing, describing, and modeling it. Now, when it comes to data collection, there are two things one has to keep in mind. It depends on the question a data scientist is trying to answer and also the environment in which he or she is working. Why did I tell this? Now, let's quickly take an example where consider a data scientist who is working in an e-commerce company like Amazon. So here the customer data is already stored in the databases, right? At the first place, why should they even store the customer data? As a user, suppose today I purchase a computer, so they can target ads of probably a keyboard, a mouse, right? In that way, targeting ads is one of the use case of storing data. They can make so there are various applications use cases of storing the data, right? So here a data scientist might what they have to do. The information is already available. They have to just retrieve the information. Consider a data scientist who is working with a political party. Consider a new policy is launched. So there is a lot of information about the pros and cons, and there's a lot of discussion about the policy all over the internet. There is no, unlike in the case of Amazon, there is no data available at one place. So here, what the data scientists have to do, probably write a program to gather the information, probably write a crawler and then gather the information, right? Now consider a case where a data scientist is probably working with some farmer or with a farmer, where the data scientists have to ensure that given a particular land, the maximum yield is produced. For that, there is no data available because that piece of land is probably there's no data available about it. So what a data scientist have to do, probably conduct different set of experiments based on the parameters like what is what are the seeds, irrigation facilities, fertilizers. So these are different like parameters, right, which would affect the yield. So what the data scientists have to do here, divide the land into few parts and then tell that, okay, this part A of the land, conduct experiment with the parameters being initialized with these variables. Like they can say that, okay, at this part of land, don't use any fertilizer, use these kind of seeds, and the irrigation facility should be at this level. So then in that way, perform different experiments and then gather data. So I see a data scientist. What is happening here? A data scientist is collecting data in all the three cases, but the way they're actually collecting the data is different in all of them, right? So that's when I said one have to understand what kind of question they're trying to answer and what environment he or she is working at. That plays a major role. The task is the same, but the environment is defining how that task has to be performed, right? Once we have collected the data, we have to store the data. Now, where do you store it? At the first place, understand what a transactional and operational data is. Consider a bank. So there is a transaction out there. That information is stored. Any patient record or student record, all these things fall into this category. And usually these informations are stored in databases, right? Databases is a structured way of storing the data. Consider a very large organization. There'll be multiple units in that organization. Each of them have their own databases, right? And if we have to perform any analytics, there is a need for integrating these data. That's called as data warehouse, where it's a collection of multiple databases, each of which being structured. Most of us would be aware of what big data is, right? Today, when we say what information is, it's not just confined to text, it's multimedia. It can be image, audio, video, and a lot more, right? So now the data is everywhere and it is unstructured. We know how to store structured data. For storing unstructured data, we can use data lakes. So if your data is structured, go for a database or a data warehouse. If it's unstructured, store it in a data lake. Once it's done, get started with the processing of data. What is happening here? The very first step in processing the data is called as data wrangling or data mungling. So why should we do it at the first place? Different organizations might have different ways of storing the data. Probably consider a company which is selling books. As a customer, I've ordered a book. So it is storing my details in a relational database. Whereas the courier service, after the delivery of the book to me, they're storing the information about the time, the place at which they've delivered, and other details in JSON format. So what data wrangling is telling is extract, transform, and load data accordingly. So that is what data wrangling is. Once data wrangling is done, there's a need to clean data. You have the data, but there can be a lot of missing values. There can be outliners. Now, how to deal with the missing values, it's left to a data scientist. He or she can replace it with a zero, or might, replace it with a mean of values. There are multiple ways to do that. It's a choice of the data scientist, but there is a need to do it. Okay, so once the data is cleaned, okay, let's take an example of us trying to collect the data of a class, okay, where we're telling that all the students have to fill the details about weight and their height. The weight and height based on units would have a range of values it might hold on, right? In order to consider all the parameters equally, there is a need for data scaling and normalization. Okay. There's one thing one would might look into. Hadoop's MapReduce is a framework which facilitates for distributed processing. So if one is interested, go check that out, because nowadays the information is humongous that it cannot be fit into a single machine. You don't have it at a place. You have the chunks of each of them distributed across. So if you're interested into distributed processing, go check MapReduce, okay? After processing the data, there is a need for describing the data. Now, how do you describe it? Visualize it and summarize it. These two steps, visualizing and summarizing, are collectively called as descriptive statistics. So in visualizing the data, consider a TV shop, okay, where they keep a track of number of TVs that are sold per day. So they do this experiment. They keep track of number of TVs that are sold per day across a month, and then they figure out the mean. At the first place, why should they even do it? Suppose so if they come to a conclusion that the mean number of TVs that are sold in a day are probably 5. So in that case, suppose if the owner sees that there are 18 TVs that are left out, he has a kind of intuition in his mind that, okay, according to the previous statistics, I might I might run out of TVs after the after 3 days. So I might have to order for the new TVs from the godown or elsewhere. So that's one way of looking at things. But consider an example. I would like to consider that there is a new drug, okay, that is introduced. So there are a set of people, and we want to see how this drug would affect the set of people in order to figure out if the drug is effective or not. What is the naive way of doing it? Okay, they might be looking into the blood sugar levels. Okay, so before introducing the drug, they can take the blood sugar levels of each of the patient, and then take the mean of it, introduce the drug, and then after a few days, they can again find out the mean. And in case if the blood sugar levels fall down, it's effective. And if it's increasing it, is it not effective? Is that the way to deal with things? No, no. A single value mean here is not sufficient. The reason is, if there might be a few people out there where for them the drug is so effective that their blood sugar levels would have gone drastically down, which might not be the case with everybody. So just a many number might not give the entire details. Try to get this right. If probably among the few people, among the few people we have conducted the experiment on, suppose say 70% of them have the habit of smoking, and due to which the drug effect has been wrong. Okay, their blood sugar levels have increased a lot. Okay, so at that point of time, the mean has increased. Does that mean that the drug is not effective? That conclusion shouldn't be made. A data scientist has to be very careful if they're dealing with summarizing data. So visualizing and summarizing is needed, but very cautiously one have to take decisions. And at this point of time, what is more important when we say a single number is not sufficient at multiple places? So in the case of TV, it might work, but in case of this drug, it might not work. So what is needed is modeling of data. What modeling does is it captures the underlying distribution and the relationship between different parameters. So if I have to tell, there are two types of modeling, statistical and algorithmic modeling. Statistical modeling is less data hungry, whereas algorithmic modeling needs a lot of data in order to perform the modeling. So let's take an example. When it comes to statistical modeling, in our previous example, we can probably if we see an observation that the blood sugar levels of the people is decreasing with as and when the number of days are increasing. Once the drug is introduced, as and when the number of days are increasing, the blood sugar level is drastically reducing. So in this point of time, we can see that there is a linear relationship between them. So here, there are only two parameters, the blood sugar level and the number of days. At this point of time, writing a mathematical equation isn't that difficult. But today, when we have a lot number of, when we are dealing with high volume data, when we are trying to deal with images, audio, video, it's not that easy to, capture the relationship between, the entities, the parameters. So for that, we have, so there is something called as algorithmic modeling, where you actually define a model and you're telling that, okay, this model will eventually learn the relationship between the parameters, which is actually not linear. Like in the case of statistical modeling, the example we were discussing on, it was a linear relationship, right? It might not be linear in this case. It can be a very, very, a very, very non-linear relationship across the parameters. It might be a very complex relationship among them. So we are telling that we will give you the data. The machine will do that work for us, where it will see the data and it will learn with time that, okay, these are the relationships between the parameters. So that's a whole section. If one has to explain about algorithmic modeling, they have to get into the details of deep learning and all. So, so the main idea about this presentation is to tell that, okay, first, if you're talking about data science, if you want to be a data scientist at a company, understand what are the tasks that are involved. Hope this presentation would have been useful. So thank you, everyone.